Okay, so we are going to do question number 54 to 59, which deals with a part of macroeconomics, that is solo growth model. And at first we would be setting up this model. The information that has been provided to us is this only, that the production function in the economy is given by yt is equal to kt alpha and lt 1 minus alpha, where yt is the output and kt is the capital stock, lt is the labor stock at time t, alpha and 1 minus alpha, those are the parameters. We have also been provided that saving propensities for two type of people in this economy is different. It is not the same, and hence those who are wage earners in this economy, they have a different savings propensity that is given by small sw, and those who are capital earners, so on capital earnings, they have a different savings propensity that is noted by SR. We have also this one information that depreciation in this economy is 0. So we would set capital depreciation rate at 0. Now we know that wages in this economy will be given by marginal return to labor. So from this equation we have just to differentiate with respect to labor, and what we get is this equation, W is equal to 1 minus alpha, and you will get an equation in capital KT and LT. So we are defining it in small kt terms. A small kt is nothing but capital KT upon capital LT, which means capital per worker. So the small kt is in capital per worker units. Hence, W is equal to 1 minus alpha, small kt alpha. In the same manner, rates will be decided by marginal return to capital, and that comes to alpha, small kt alpha minus 1. So these two you can easily get from this equation only. One more information is this, that population growth rate of this economy is n. Population growth rate is n. That means population at any time t plus 1 will be given by 1 plus n into lt. So this is one equation we are having. Now, what would be the total savings at time t? We have to derive an expression for st. So what will that be? That st would be nothing but total savings made by those who are wage earners and total savings made by capital interest earners. So this term WLT is nothing but total wage earning in the economy, and SW is the saving propensity. So this is total savings made by wage earners. SR RKT gives, this is the propensity to save by the interest earners, and RKT is the total savings on the employed capital KT. These are the returns, total returns, and this is the savings rate. So this is how we get total savings in this economy at any time t. Now we have to derive capital augmentation equation. So how does capital move from one period to another period? So that's quite easy to see, that in the next period kt plus 1, since capital is not depreciating, delta is equal to 0, so we will have kt intact, whole of the capital stock in time period t will be there, plus the savings which are made here, these savings are invested directly. So we have this expression kt plus 1 is kt plus it, that is equivalent to kt plus st. Now what I have done, I have replaced the expression for st in this equation here. So in this manner we get capital augmentation equation. From this capital augmentation equation we can go to capital augmentation equation in capital per capita or capital per labor units expression. How will we get there? That can easily be done by dividing this whole expression by LT. If we divide this expression by LT, what we get? KT plus 1 upon LT, that is here. This KT will be divided by LT, and hence it becomes small kt. This LT will cancel out, we will get this, and this KT will be divided by LT to get a small kt. So this is the expression here. Now this LT kt plus 1 upon lt, this term is not well defined, so we have to change it. We have to do a little change here, and we will replace this lt from this equation. We can write lt is equal to lt plus 1 upon 1 plus n. So I have done just that, and now we have got kt plus 1 upon lt plus 1 into 1 plus n. Now this is small kt plus 1. So we got capital per capita in the next time period, that is here, and this whole expression comes to be like this. Now again, what I have done is I have replaced this w and r from these two equations. So wedge rate, you can write this expression here, and for r you can write this expression here. This whole thing solves down. This is a small equation. This is capital augmentation equation and capital per capita terms. Now we are equipped to solve these sequence of questions from 54 to 59. One additional information you must get, that if there is a tax in this model, if there is some government and it is applying some type of tax rate on some type of earning. Let's say in this question there is one point where in these questions there is one point where wage earners are taxed. So if this wage earning is being taxed at some rate tau, then this total earning will reduce, and we will write WLT bracket 1 minus tau. So this will be the expression here. And since the question also says that the tax collected will be transferred to capital earners, so in that way total tax collected from here will be transferred to this side. SW and SR, they will remain intact. So in this manner we can define savings, and these savings will be coming here, and in this manner we can devise a whole new set of this equation. So now we are ready to go ahead, and we will be doing all the questions that are coming forward. So now I am taking this equation here, the capital augmentation equation, small kt plus 1 into 1 plus n is equal to this whole expression here in numerator. So taking this upside, so we have got our equation. Now coming to steady state, the steady state is defined where capital per capita in the next period kt plus 1 is equal to capital per capita in current time period t. So this is how steady state is defined. Kt plus 1 is equal to kt. If we put this value here, so what we get? Kt plus nkt, so kt and kt would cancel out, so we would get nkt, that is equal to this expression here is written. Now if we find the value of kt, this comes to this value. Now let us analyze this equation. What this says, this puts aggregate savings in the numerator part, population growth rate in the denominator, and it is raised to a power 1 upon 1 minus alpha. So this is the solution given as the steady state of the economy. Now what the question asks, the problem 54 asked us to find out that that's a question of comparative statistics, and we have to analyze what would happen when alpha would increase with the steady state. So now we have to put values. SW is equal to 0 and SR is equal to 1. If this is 0, this vanishes and SR becomes 1. So this is just alpha upon n power 1 upon 1 minus alpha. So in that case we get kt star is equal to 1. This would vanish out, and we will get alpha is SR is 1, so alpha upon n power 1 upon 1 minus alpha. Now it is if SW is equal to 0 and SR is equal to 1. So in this case, this is the steady state. To find out how kt star would behave if alpha would change, we would differentiate it with respect to alpha, and we would find it that we get a negative expression. So that's all we have to do for question number 54. Moving on to question number 55, we have been given that this SR now is 0. So if this SR is 0 and SW is some positive fraction, so we get KT star is equal to 1 minus alpha SW, and this SR is 0 now, so this term vanishes, upon n raised to power 1 upon 1 minus alpha. And we have been asked what would happen if the parameter value n changes. So clearly n is the denominator, n is in the denominator, so with n the value of KT star would decrease. So we have got our answer for problem 56. The correct option is second one. Moving on to question number 56. If such type of conditionalities on SW and SR are not given, then we are left with one equation we already have derived. So this is the solution with us. In that case, if SW and SR both are positive fractions and SW is less than SR, in the long run, the capital labor ratio in this economy approaches a constant value that is given by this number only. So this was pretty forward, and if you have solved question number 44 and 55, 56 is already solved. So you've got 3 questions in a row. Now, moving on to next question, it is asked that there is some tax rate in the model and we are taxing the wage earners and giving the tax collected, redistributing the tax revenue in form of transfers to the capital earners. So what would happen? What would happen is this, that this part will be taxed, and after taxing this, after taxing the wage earners, we will be transferring it to capital earners. So in that case, what would happen to the total savings, aggregate savings? Since SW is, we have been given that, we have to assume that SW is less than SR, and we are transferring from the people who are saving less out of their income to people who are saving more out of their income. So in that case, total savings in the economy is bound to increase, and hence the steady state growth rate, the steady state capital stock would also increase. So that's how we can intuitively solve problem number 57. However, if you want to do a detailed exercise, we can start fresh and we can go back where we had defined total savings and put tau parameter there, and we would get a different equation here, KT, in terms of tau now. So then for comparative statics, we can derivate the new equation we get in terms of tau, and we can verify that indeed with increase in tax rate, KT star increases. So this is how it would be easier to solve question number 58. Question number 57. Let's move on to question number 58. 58 defines that labor growth rate in the economy is endogenous. So for that, we have to change the model a bit. Let's come to question number 58. So in question number 58, the growth rate of population, the population growth rate is endogenous, and the growth rate is given by capital A, small kt, for small kt below some given level, constant level, small k bar. If growth and 0 if this kt is much greater than k bar. So this is the given expression in our question. Now we know that if growth rate is n in an economy, then we just write 1 upon L dl upon dt is equal to n. So this expression converts to this thing. LT plus 1 is LT 1 plus n. So by analogy, we can easily write, however we can derive this formally too, but I am going in informal way, and I would prefer shorter exposition, so I would write, if I can write this expression as capital LT plus 1 is equal to LT 1 plus n, then I can easily write that LT plus 1 is equal to LT, and in place of n I can put capital AKT, so LT 1 plus AKT for first condition. And since growth rate is 0, so LT plus 1 is nothing but LT itself if the second case holds. So this is our dynamic equation for labor growth rate. So, using this, LT plus 1 is equal to this case or this case. Using either of these cases, we can derive KT star for both parts. For the first part, if you go back and solve all the exercises again, then we would get KT star. In the first case, KT star would come out to be this expression, 1 minus alpha SW plus alpha SR upon A. Remember that we were having a value n here. Now we are not having n anymore, it's A. And here it was 1 minus alpha, now we are having 2 minus alpha. So we have got two steady states, one is 0 and another is this one for the first case. And for the second case, we get only one steady state, and that is KT star is equal to 0, and we have no other solution than that. So now let's consider our question. The question asks that what in the long run capital labor ratio in this economy would be given by what expression. Let us assume what would happen if the initial state, if the initial value of KT star, initial value of KT, that is K0 is 0. If it is 0, we cannot assume this, that any economy would start with the capital per capita to be 0. So this is very trivial, and we can just leave it. And moving on, if there is some capital stock, some positive value, some initial value for capital stock per capita, then this solution holds in the first case. Let's see. Since we have been given that if the value of this K bar is greater than this value here. So we know that this KT star lies well before this expression expires. So before this K bar, we have K star. In short, we have our K star is less than K bar. So in this case, what would happen in a graphical way, if we can write this thing here, and this is our 45-degree line, a small kt and a small kt plus 1, then this value is kt star, and as per the question, this k bar is greater than kt star, so k bar lies here. So if k bar lies at this point, then up to this point this equation holds, and hence this steady state is possible. So we have got one stable steady state here in this case, the first one. So we just know that if the economy starts beyond k star, if k0 is way beyond k bar, if the initial value is in this region, then this part of the labor growth rate holds, and in that case kt star is equal to 0 is the only solution. So we know that in that case the graph goes to infinity. It always lies above the 45-degree line. So in that case the second case holds after this k bar. So we can write that this part of the expression is not valid. So after k bar, this is just going upward and would never cut 45-degree line. So we know that capital per capita equation has become unbounded. So option 4 states the right thing, that in the long run, the steady state level of capital per capita approaches infinity if kt is much greater than k bar, and this equation holds, and hence we are on this line that is going unbounded. And if it is not the case, if the other case is holding, if the initial value of kt is less than k bar, then since kt star is a stable steady state, if you are here, you will go back to here, and if you are anywhere in between, you will move on to kt star. So that they are the two solutions. Hence the option 4 is the correct option for this equation, for this question. Moving ahead, problem 59 asks something about comparative statics. It asks that an increase in parameter a, what will happen if we increase this value of a. So it's very intuitive. You can see that the solution lies here. Solution is here. So if k naught initial value is lying, if k naught is less than k bar and this equation hold, and this is the steady state, in that case it increases the long run kt star. So that's the answer. Problem 59 can be solved directly, and hence we got the solution as option 3. So that's all for this part.